Hello students, good morning to all. Welcome to your beautiful channel Firjan. See, today's concept is parallel plate capacitors. It belongs to electrostatic potential and capacitance, second lesson, 12th standard. Previous video or previous lecture we discussed capacitance, capacitor, spherical capacitor, their introduction we discuss. In this one we discuss parallel plate capacitor. In this one how energy is stored, charge is stored, how charge is distributed, that we discuss. It is the 10th video. See, parallel plate capacitors. Parallel plate capacitors. In this one, see here, before that we discuss capacitor, capacitance, spherical capacitor. So capacitor na device which stores energy and gives energy suddenly to the electrical device, and that device starts it. For example, fan, electric motor, it requires more current. How much na? 25 to 50 amperes of current, means that much of current it requires. For normal battery or electrical circuit not supplies that much current, it will give less amount of current, but we have special device. That device name is capacitor, which stores more energy, nearly 25 to 50 amperes of current or energy. It will give suddenly to the motor, fan, camera flashes. So this, then it will overcome the static friction starting, so that overcome and start the device. So for that purpose we use capacitor. Capacitor is the device which stores large amount of energy and gives suddenly at once. So that we call it as capacitor. So capacitance. Capacitance is the property which has ability to hold the charge or energy. So that property we call it as capacitance. Capacitance equal to Q by V. Q means charge, V means potential. So charge in a unit coulomb and potential in a unit volt. Coulomb per volt is the unit of capacitance in SI system. See, farad, coulomb per volt we call it as farad. So it is the unit of capacitance. We have spherical capacitor. This is spherical capacitor. What is the capacitance of the spherical capacitor na? C equal to 4 pi epsilon naught R. Already we discussed in previous lecture or previous video. So what is the capacitance of the spherical capacitor? 4 pi epsilon naught R. So it is not giving sufficient capacitance, so it will provides low capacitance. And in this one it is not bounded, so energy is not bounded, energy will be distributed from R to infinite distance. So that's why these spherical capacitors are rejected. So instead of spherical capacitors, introduce parallel plate capacitors. In this one energy is bounded, their energy is distributed in spherical capacitors. Because of distribution of energy, spherical capacitors are rejected and parallel plate capacitors are introduced. See, for example, parallel plate capacitors. In this one, parallel plate capacitors, see, two plates here. It is the one plate. See, it is one plate. See, one more plate here. See, this we call it as parallel plate capacitor. See, it has some conditions is there. Its area is A1, its area is A2, charge here plus Q, here charge is minus Q. See, it is plus Q charge na. See, here minus Q charge, distance between them is D. See here, this parallel plate capacitors, what now here? See, electric field lines positive to negative. See here, electric field lines is moving from positive to negative and end at another plate. It is the bounded, in between them is their electric field lines. But in case of spherical capacitor, see, it is the spherical capacitor. In this one, energy is distributed. See, electric field lines from where to where? Here to conductor to infinity it will moving. See electric field lines. Yes na. So it is distributed, energy is distributed where to where, surface to infinity it is distributed. That's why these spherical capacitors are rejected and introduce the parallel plate capacitors. Parallel plate capacitors, energy is bounded, electric field lines are bounded between the plates. So that's why it will give more capacitance, it will give very low capacitance, energy is not bounded, it energy is distributed. Because of that it will be rejected. Now see here parallel plate capacitors, it has plus q charge, it has minus q charge, its area is a1, its area is a2, distance between the plates is d. See here two conditions we have. What is the first condition now? D is definitely very less than area, and second condition is a1 equal to a2. So means area of the plates are equal, then only equal charge is distributed, means equal charge is in this one. See d less than very less than a, so a1 equal to a2, these two conditions satisfy. See here d very less than a means it will behaves like a infinite plate. Whenever it will behaves like infinite means, so capacitance is increases, capacitance increases. D less than, how much less than, that much capacitance increases, that much capacitance increases. See here why we can say it will be behaves as infinite plate now. See for example board we can compare this dot. So dot is very small comparing with the board, this case. So board we can say that infinite plane, infinite plane, like that here d is very small, that case this plate, each plate will be behaves as infinite plate, infinite plate, infinite plate, in between the distance is very small, that case capacitance is increases. See in the same way a1 equal to a2, this area same. See here, here plus q charge, here minus q charge, these are the parallel plate capacitors. It has same quantity of charge, electric field is bounded between the plates, area of this plate and this plate are equal. So d is distance between the plates is very less than a, how much less than is there, that much capacitance increases. So that's why we can say this plate will be behaves as infinite plate, we call it as related term this is. So infinite plate we call. So infinite means very not infinitely, infinity it will be extended. So means it will, it is the relative term. See for example dot comparing with board na, plane, plane of board it is very small, so that's why this board we can call it as here infinite plane, like that here it is infinite plane we can say. Why? Because d is very small, so because of that it plate will be, we can say that infinite plate. So this d is very small, how much small, that much capacitance increases. It is, these are the conditions for parallel plate capacitor. For example, see spherically shaped plates, parallel plates, spherically shaped parallel plates. Here see positive charge, here negative charge, it is plus q, it is minus q, distance between the plates is d. Yes na. See d is, what is the condition here, d is very less than a, its area is a1, its area is a2. One more condition is what here, so a1 equal to a2, area of the first plate which is equal to area of the second place. D is very less than means it will behaves infinite plate, capacitance automatically increases. For increasing capacitance the distance between the plates is reduced, means decreases. Yes now, how much less distance is there, that much capacitance increases. See here, here we are saying this one has plus q charge, it one has minus q charge, so both are same magnitude. How it will happen now? See we have two methods is there for that. First one now, for example see here, here we can take dq charge and store here, we can take in this plate dq charge and store here, it will get minus, here it will get plus. For example see here, how to get same equal charges now? See both the plates is getting equal magnitude of charge now. See here, here we can take dq and store here, we can get this one plus, it one minus. One more dq we can take here minus, here we can get plus. One more dq we can take here minus, here we can means plus. So means what now, here how much dq we are taking from the this plate and store to here. So means here minus, how many is there, 3, here plus. So like that here plus q, here minus q. So means both plates are getting same charge. Like this we can, this is the one method. So one more method, see here, it is the plate, parallel plate. So one more, so one more, now here it is the plate. See, it is connected to cell, connected to cell, it is positive, it is negative. So current is going like this, moving like this. See here, in this one we can take electron, so I'm moving this. So means cell na, cell supplies, cell is the energy supplied source, it's not supplying electrons, it will transfer the electron. So it means this will, electron is moving this direction and move to here, it reaches to here, so we can get minus here plus. One more electron moving and reaches to here, minus here plus. One more electron moving here, minus here plus. See, one more electron, so means plus minus, means here what, equal amount of charge we are getting in this one, in this one. See, it is plus q, it is minus q. Like that, means in parallel plates we are getting equal amount of charges. Some cases unequal is there, that also we can distribute. How na, we discuss later. So up to this understood na. See, parallel plate capacitor means two plates, one is this one, so another one, it area is a1, it area is a2. So here distance between the plates is d, here charge is plus q, charge is minus q. Electric field lines are moving from positive charge to negative charge. So that's why electric field lines are bounded between the plates. So this, it is, this plate has two conditions is there. What is that now? D is very less than A. That case this plates behaves as infinite and capacitance is increases. See, A1 equal to A2. So this area of this plate which is equal to area of this plate. So these two conditions satisfied. So then it it is the parallel plate capacitor. So it is spherically parallel plate capacitors. So how the charge is, equal charges on these plates now? So we can take, we have two methods is there. One, so dq charges we can take here and keep here. So means it gets negative, it gets positive. One more dq charge, place here plus, here minus. One more dq charge, here plus, here minus. See, this is one method. So we are getting equal amount of charge on each plates. So another method is, it is connected to cell. Cell is the energy supplied source. It not giving the electrons. It only transfer the electrons from one place to another place. See, in this plate, electron is taken and moving and reaches to here. So here electron na coming from here, so plus we get, taking, so minus plus. One more electron, so place here, one more electron here. So means like this, means it will get same positive charge, negative charge, equal amount of positive charge, equal amount of negative charge getting. So like that we are getting equal amount of charge on both plates. Yes, na? One is plus, another one is minus. Now we discuss what is the capacitance of the parallel plate capacitor. Capacitance of the parallel plate capacitor. See here, it is the parallel plate capacitors. See, this is first plate. Yeah. See, one more plate here. See, we can take this one. See, one more plate. See, it is the second plate. Its area is A1. Its area is A2. See here. Here we can get plus Q charge. Here minus Q charge. How we are getting, we know already. Yes, now it is plus Q. Plus Q. Yes, now it is minus Q. See here, the distance between the plates is d. Here two conditions is there. First one is what? D is very less than A. Very less than A means that case it behaves like infinite plate and the capacitance is increases. Capacitance increases. Second one, so A1 equal to A2. Area of first plate which is equal to area of second plate. That case electric field lines are starting from plus charge and reaches to terminated negative charge. See here, plus to minus. So plus to minus, electric field lines. These are electric field direction. It is the electric field direction. In this case, see here, due to plus charge, what is the direction of electric field now? This is the direction of electric field, E1. Due to negative charge also same direction. See, it is E2. Yes, na? See, due to first one, what is the electric field? E1. Due to second plate, electric field is E2. So both are in same direction. Same direction means we can add it. So means here we can write E net. What is the net electric field due to plates na, parallel plates na? E1 plus E2. E1 plus E2. See here, electric field due to positive charge. Positive charge and electric field lines are radially outwards. Negative charge na electric field lines are inverse, radially inverse. That's why both are having same direction. E net, net electric field equal to E1 plus E2. Electric field due to first plate, electric field due to second plate. For each plate, electric field due to single plate na, what is the formula na here? Sigma by 2 epsilon naught. This one we learn in electric charges and electric fields. In this in that lesson we discuss this one. So what is the electric field due to infinite plane sheet na? This is the electric field. Sigma E equal to sigma by 2 epsilon naught. Sigma by 2 epsilon naught. Here sigma means surface charge density. Surface charge density. Surface charge density means we can represent sigma, that means q by a. Q by a. Q means here charge, a means area, surface area. So means surface charge density sigma equal to q by a. Q means charge, a means area. Charge per unit area is called surface charge density. Here see electric field due to infinite plane sheet. Now this is one infinite plane sheet, it is another infinite plane sheet. What is the formula? Sigma by 2 epsilon naught. Here we can use now due to this one E1, due to this one U2. So means E1 now we can write here sigma by 2 epsilon naught. Why? Because here area same, here area same. See, plus sigma by 2 epsilon naught. So what now? E net equal to sigma by 2 epsilon naught, sigma by 2 epsilon naught. So denominator same, numerator added. What we get now here? 2 sigma by 2 epsilon naught, sigma 2 cancel. What we get now? Net electric field due to parallel plates na sigma by epsilon naught. I write here. So net electric field due to parallel plates na sigma by epsilon naught. It is the net electric field due to these two plates. So sigma means what here? Charge per unit area. We can write here E net equal to sigma means q by a, q by a into epsilon naught. So it is the net electric field due to both plates. It's not charge is same, plus q minus q. So means area also same. So what now? Epsilon naught, medium. So means E net equal to q by a epsilon naught. See here, it is the positive plate charge, it is the negative plates. What is the direction of electric field lines? Positive to negative. So we know electric potential is decreases in the direction of electric field. See here, it is the electric field direction. Here from here to here, what now? Electric potential. So electric potential decreases in the direction of electric field. In the direction of electric field means here starting now. So maximum electric potential, here minimum. What is both now? Here difference is, we can write it as delta V. Delta V. See, we can write here delta V. What is the relation between electric potential and electric field now? We know. So that is delta V equal to minus E dot delta R. So this is the relation between electric field and electric potential. This also we discussed in electric charges and electric fields. This lesson we discussed this one. So what is the relation between electric potential and electric field na? Delta V equal to minus E dot delta R. Minus E dot delta R. We can write here only, we can take magnitude. So means delta V equal to what? E dot delta R means here D we can take. When electric field is E, here potential is delta V. What is the distance between them now? Here D. We can take E dot D. See here delta V equal to E dot D. What is E here? Q by A epsilon naught. I write here Q by A epsilon naught into D. It is the potential difference between the parallel plates. What is the potential difference between the parallel plate? Now delta V equal to Q by A epsilon naught into D. So we want here, what is the capacitance of the parallel plate capacitor? What is capacitance now? Here see, capacitance equal to actually Q by delta V. Why we are writing delta V now? Here between two plates, what is the potential difference? Delta V. So that's why we can write Q by delta V. C equal to what? Here C, delta V means here Q by A epsilon naught D. So Q na charge same. So delta V means we can write it as Q D by A epsilon naught. So Q cancel. What we get now? Here it will changes to numerator. C equal to epsilon naught A by D. It is the capacitance of the parallel plate capacitor. What is the capacitance of the parallel plate capacitor? C equal to epsilon naught A by D. C equal to what? Epsilon naught A by D. So means capacitance of the parallel plate capacitor. I write here. So what now? Capacitance of parallel plate capacitor. Plate capacitor. See, capacitance of parallel plate capacitor is C equal to epsilon naught A by D. Here epsilon naught means permittivity of permittivity of free space. Permittivity of free space. A means here area of the plate. Area of plate. D means distance between the plates. Distance between plates. These are the terms related to capacitance. What is the capacitance of the parallel plate capacitor? Na? C equal to epsilon naught A by D. Yes, na? How na? This is the process. This is the parallel plates. It is plus Q, minus Q. Electric field is positive to negative. So what na? D less than, very less than A condition. So A1 equal to A2. So means area of these two plates are equal. So that case, what is the net electric field na? Here due to plus away from the plate, due to minus towards the plate. So both are in same direction, E1, E2. So here it is the net. So net electric field equal to what? E1 plus E2. So E net equal to means electric field due to infinite plane sheet na. This is the formula. Single plate means this is the formula for single plate. Single plate na infinite plane sheet na. So this is sigma by 2 epsilon naught. Here we can take this is single, this is single separately na. Sigma by 2 epsilon naught, sigma by 2 epsilon naught. What we can take 2 sigma by 2 epsilon naught, 2 cancel, sigma by epsilon. It is the net electric field between the parallel plates. See, E net equal to sigma means surface charge density. Surface charge density means charge per unit area. Charge is Q by A epsilon naught. So what is the net electric field now? See, due to parallel plate capacitors na, E net equal to Q by A epsilon naught. We want here potential difference. Here one potential, here one potential. It is the starting electric field line, it is ending. So electric field line in the direction of electric field, electric potential is decreases, means here definitely high potential, here low potential. What is the difference now? Here we can write delta V. So that we can write here delta V. So means we know what is the relation between electric field and electric potential now. Delta V equal to minus E dot delta R. So that we can write here. So magnitude only we can take E dot D we can take now. Why now? Here distance is D. So that's why we can write delta V equal to E dot D. So delta V equal to E means this value Q by A epsilon naught D. Q by A epsilon naught D. So what we want here? Capacitance of the parallel plate capacitor. Capacitance formula is Q by V. Here why we take delta V now? Potential difference is there. Here higher potential, here lower potential. So that's why we can take delta V. So means C equal to Q by delta V means here Q by QD by A epsilon naught. Q cancel, epsilon naught A by D. So epsilon naught means permittivity of free space or vacuum. A means area of the plate, D means dimensions, sorry, distance between the plates. See here, this capacitance of the parallel plate, capacitance of parallel plate capacitor depends on two conditions. What is that one? First one, dimensions of the conductor or capacitor. Dimensions of the capacitor, it will depends on. So second one is property of the medium. Property of medium. So means dimensions change na, capacitance change. Property of medium, medium change na, capacitance change. Medium means this one, epsilon naught. Permittivity of free space or vacuum. This epsilon value change na, is capacitance change. So dimensions of the conductor na changed. So area change na, so it's also capacitance changes. This is the basic information about the capacitance of parallel plate capacitor. What is the capacitance of parallel plate capacitor na? C equal to epsilon naught A by D. C equal to what? Epsilon naught A by D. So now this is, so next we discuss what is the force exist between the plates due to one plate on other plate. So that we discuss. See here, before that we discuss first See for example, first some problems. See first problem, see here, find work done work done by external force, external force if second plate, second plate moved from d to 2d distance, d to 2d distance. For example, see here, it is the first plate, yes, it is the second plate, it is moving from d, this distance is d, its charge is plus q, it is minus q, it is plus na, it is minus, electric field lines or like this is there. See, this distance is d, this plate, first plate is fixed, only second plate is moving. See here, second plate, it is the first plate, it is fixed, it's not disturbing, second plate only moved. So how much distance na? See here, 2d distance it moves, 2d distance it moves. See here, here plus q, here minus q, electric field lines. See here, same only. Here we want to find out what is the work done by external force moving second plate from d distance to 2d distance. What is the work done? So work done means force into displacement, force into displacement. See here, what is the work done by external force if second plate is moved from d to 2d distance? So for that we have formula is there, work done by electric force. So that work done by electric force now, what the formula now here? See, work done by electric force or external force, what now here? Q square by 2c. This is the formula for work done by work done by external force, q square by 2c. Here c, c means we know what is the c, capacitance of the parallel plate capacitor. This case, what is the capacitance? This case, what is the capacitance? That we find out. It is the initial case, it is the final. So first here we find out what is the capacitance of the initial capacitance, final capacitance. Charge same na, here plus q, here plus q, here minus q, here minus q. Charge is not changed, only here what? Capacitance change. Why? Because distance change na, capacitance changes. Distance less is there, capacitance increases, distance more is there, capacitance decreases. That's why here work done by external force we can write here, see, that equal to work done by external force equal to, see here, q square by 2c final minus q square by 2c initial. Means q same, that's why same we can write, q square by 2. So means in final capacitance minus initial capacitance. Yes na? See, what is final capacitance? See here, capacitance equal to what na formula? So epsilon naught a by d for this initial capacitance. For this final capacitance na, epsilon naught a by distance is here 2d. This is the final capacitance. See, this minus this, we can write here work done by external agent or external force, that equal to q square by 2 final na, what is final? So epsilon naught a by 2d, epsilon naught a by 2d and minus q square by 2 epsilon naught, initial is 2 epsilon naught a by d, 2 epsilon naught a by d. It will changes to numerator now, work done by external force, that equal to q square 2d by 2 epsilon naught a, here q square d by 2 epsilon naught a. Here denominator same na, what we can do? Work done by external agent. See, 2 epsilon naught a same, we can write here q square 2d minus q square d. So what now we can write? 2d minus d. We can write here q square d by 2 epsilon naught a. So actually here what we get now? Work done by external force, work done by external force na, here see, work done by external force equal to q square d by 2 epsilon naught a. This is the work done by external force for moving second plate from d distance to 2d distance. What is the work done by external force na? Q square by 2 epsilon naught a. This is the formula for finding some distance d to 2d distance moving. What is the work by external force? What now here? Q square by 2 epsilon naught a. What we are doing here? It is fixed. First plate is fixed. Second plate only moving. Where to where? D to 2d distance. So I write here work done by external force now Q square by 2c. So work done by external force equal to Q square by what it is final position? It is initial position. So means C final means 2c final minus Q square by 2c initial. Q same na, that's why only it will change. So capacitance of final capacitance, initial capacitance. Work done by external force Q square by 2 epsilon naught A by 2d. Here Q square by 2 epsilon naught A by d. Why now here capacitance is epsilon naught A by d. This distance. This distance capacitance is epsilon naught A by 2d. Just we can write here. So changes to numerator. So what Q square 2d by 2 epsilon naught A. Here Q square d by 2 epsilon naught A. Subtract now, we get work done by external force Q square 2d minus Q square d by 2 epsilon naught. Why? Because denominator is same. So just do 2d minus d na. See, we can write d. So Q square d by 2 epsilon naught. This is the work done by external force to move the plate, second plate from d distance to 2d distance. D distance to 2d distance. Now we can discuss energy stored in parallel plates. So how to store the energy? So that we can parallel plate capacitor. Energy stored in parallel plate capacitor. See, for that now, see here, for that, so energy I write here, energy stored in parallel plate capacitor. Parallel plate capacitor. Parallel plate capacitor. See here, energy stored in parallel plate capacitor. So we can take here two plates. It is one. It is so second one. It is the second plate. Here see, it is its area is A1, its area is A2, its charge is plus Q, its charge is minus Q. Here see plus Q, yes now here minus Q. See, distance between them is D. Actually, what is the condition here? Two conditions is there. One is what? See, definitely first one, D is very very small than area. Yes na. Second one, what is the condition? So means A1 equal to A2. So means area of first plate which is equal to area of second place. Electric field lines moving from positive to negative. Yes na. So this we can say parallel plate capacitor. In this one, how to store energy? So that we discuss. For example, see here starting here no charge is there. For example, so we can take here. So this is plate means no charge is there. Here this one another plate. So no charge. So initially no charge is there. See here, for that what we can do now here? So we can take here dq charge. Dq charge we can store here. What we get here? Plus charge we can get here, minus we get. See, when we can take dq charge or dq element from the first plate or second plate to first plate, what happen now? Here it gets negative, here we get positive. So positive means positive charge, so it has some electric field. Negative charge, it has some electric field and electric potential. So we can take second charge. For taking second charge also, what now? Here already negative is there, negative created. So means what happened? Repelled. So here we can place now for storing here. So we have to do some work. Why? Because positive, it is positive, positive now repelled. So means for that we have to do some work done and storing charge and taking from here to here, we have to do some work. So that we can say that dw means work done by external agent. So we have to do against this field or this field, we have to do some work. So that work will be stored in the capacitors in the form of energy, that we call it as energy stored in the parallel plate capacitor. So initially no work done. Why? Because no charges is there. We can take here dq charge and placing here and store here. So means it gets positive, it gets negative. Next charge we can take now. That case definitely we have to do some work. Why? Because it is plus already plus is there, again we can take plus. So what happened, repulsive force is there, here minus is there, for taking also difficulty. Why? Because here negative charge created, it repelled. So we have to do some work on dq. That work here is stored in plates in the form of energy, that is called as energy stored in the plates. See, t equal to 0 time, no charge, so charge is 0, potential is here 0, so capacitance is c. Yes, now see here 0 time, no charges is there, we can take dq charge and place here, it plus it minus, one more charge we can take here plus here minus, so we get now here minus, now it will repelled, so minus minus, here plus repelled. So that's why we have to do external work, means we can write here, see, work done by external agent in bringing each dq element from this plate to this plate, so means from plate 1 to plate 2, what now, we have to do some work on charge, work done by external agent in bringing each dq element from one plate to another plate is stored stored in the form of energy, in the form of energy. So that we can say that electrostatic potential energy stored in the plates. So t equal to t time, after t time, what now, here minus q charge, here plus q charge, so distance is d. See here, after t time, what we can get now, here charge q, so what is the potential difference now, here charge is q by c, capacitance is c. So what is the charge after t time now, so here plus q, here minus q. See here, again you can take here dq charge, here store, so plus here minus here, like this it will takes place. So means here up to what, plus q here, here minus q. See, means we can write here t equal to infinity time, what na charge is total charge q, and potential difference is capital Q by c, and capacitance c only. Yes na. So means here t equal to 0 to t equal to infinite time, what is the charge, q equal to 0, q equal to 2, means here this case total work done, total work done by external agent we can write here, see. So for placing q charge, what we can write here, see, delta v equal to work done by external agent in bringing dq from this, what here dw work na, small work, this dq na dw work, this dq dw work, this dq dw work, what happened here, this all works are added, we can take the integration. See, first delta v equal to what, for that only small the work we can find out, delta v equal to what, dw external agent by dq. So from that, what we can write, dw equal to delta v into dq. So means for taking each charge from this plate to this plate, what is the work done now, delta v into dq, delta v into dq. See, total work done by external agent in bringing charge 0 to capital Q, that we find out. See here, that we can write now, dw equal to integral dw, all dw's we can add it, we get the total work done. So the total work done equal to what, integral 0 to q, what now here, delta v dq, delta v dq we can write, actually q dq we can write. Yes na. So delta v dq we can write. So delta v means what here, delta v equal to what, q by c, we can write here dw equal to integral 0 to q by c dq we can write. See dw na, so w we can write w by external agent, work done by external agent. See here 1 by c we can write outside, why, because constant c is constant, 0 to q dq we can write. See here, work done by external agent, that equal to 1 by c q square by 2 we can get. So why not, integral q integration is q square. So we can write where to where, 0 to capital Q. So we can write here work done by external agent equal to q square by 2, 1 by c is common, Yes, now q square by 2 minus 0 by 2. What we get here? Work done by external agent equal to q square by 2c. So this is the work done by external agent in bringing each dq charge from one plate to another plate. That all work done added, we get the total work done for reaching plus q and minus q here, for storing plus q charge in one plate and minus q charge one plate. What is the total work done now? Work done by external agent q square by 2c. This is the total work done. Yes, now so this total work done will be stored in the form of energy, that we can write delta u, that is q square by 2c. This is the energy stored in parallel plate capacitor. That energy equal to what is the formula na? Q square by 2c. Q square by 2c. This is the energy stored in parallel plate capacitor. So again listen once, what we are doing now, it is A1 area 1 area 2, A1 equal to A2, D is very less than A. Why? Because D, how much less is there, capacitance that much increases. See here, plus Q minus Q. How to store the plus Q and minus Q charges? Now here we have to do some work. See here, this is empty plates first, neutral, so we can take here dq charge and place here, no work is done. Second one, we have to do some work. Why? Because here minus, here plus, for taking also minus is there repelled, so placing also here plus is there repelled, so we have to do some work. So that is dw by external agent on dq charge. So next charge we can place here up to what, minus t equal to 0 time, no charge, t equal to t time, minus q here plus small q here. So that is q equal to small q. Delta V is what here, charge per capacitance. Charge is q, capacitance is c. See after again we can t equal to infinite time. So this case, what is the work done now? Here potential, now we can write delta V equal to work done by external agent by dq for each case. This is the potential developed in this plate and this plate, that is we can write delta V, potential difference, work done by external agent dw, small work, by dq, small charge. So from that what we can write, dw equal to delta V dq. T equal to infinite time, how much charge we are placing? Capital Q plus Q, capital minus Q. So what is that potential difference? Delta V equal to Q by C. So work done by, total work done by external agent in bringing charge 0 to capital Q. How much work is done? So that means here small work for small dq, small work, small dq, small work. So this all added, we get the total work done, that we can write integral dw. That is integral dw now 0 to q, where to where charge is reaching? 0 to capital Q charge. What is the formula? Delta V dq. Delta V means q by c dq. So q means 1 by c is constant, we can write outside, q dq, q integration q square by 2, first upper limit, later lower limit. We get here work done by external agent equal to q square by 2c, that will be stored in the form of energy, that is delta u equal to q square by 2c. That we can write delta V, delta u means u final minus u initial, that equal to work done by external agent, u initial 0. So we can write u q square by 2c. We can write what is the energy stored in the parallel plate capacitor na, u equal to q square by 2c. Next we can discuss what is the force exerted on one plate due to other plate. So that we discuss. See here, what is the force exerted on one plate due to another plate? See here, force exerted on one plate due to another plate. Another plate na, see here, first here, this is the first plate. This is the problem actually. It is the first plate. See, it has a plus q charge. One more plate here, it is second plate, it charge is minus q. Here see, here distance between them is small d, it area is a, it area is a. Why not? Equal charge, equal area. So here plus q, yes na. Here see, here minus q. So electric field lines is positive to negative, yes na. See here, what we find out, force exerted on one plate due to another plate. So due to this plate, what is the force exerted on this here? First we can write what is the electric field due to this one on this one. So that is electric field is this one, E1, due to this one electric field is u2. Yes na, see what we can write now, see electric field on second plate due to first one, we can write here, see e21 means electric field, electric field on second plate due to first plate. So E21 means electric field on second plate due to first one, due to first one. See single plate na electric field formula is sigma by 2 epsilon naught. Here we can write E21 equal to sigma by 2 epsilon naught. So sigma means surface charge density, epsilon naught means permittivity of free space or vacuum. So sigma means what we can write, so means charge per unit area. What is the charge here? Q, area is A. So we can write here E21 equal to Q by 2 epsilon naught A. It is the electric field due to first plate on second plate, means electric field on second plate due to first one. What? Q by 2 epsilon naught A. See here, we want here force on second plate due to first one. So that means force means what actually? Q into E. So charge into electric field. So Q means what here? Capital Q. So electric field means Q by 2 epsilon naught A. So we can write here force on second plate due to 1 Q into Q square by 2 epsilon naught A. It is the force on second plate due to first plate. What we can do now? Here see, it is plus Q minus Q. Electric field due to this one. What is the on the second plate now? That we can write E21. So means electric field on second plate due to first one. So that is. So we can write here electric field now for single plate sigma by 2 epsilon naught. I write here sigma by 2 epsilon. Both plates na sigma by epsilon naught. Single plate na sigma by 2 epsilon naught. See here sigma by 2 epsilon naught. So electric charge na Q by A, we can write Q by 2 epsilon naught A. Epsilon 2 epsilon is there, epsilon naught is there. A we can write Q by 2 epsilon naught A. Electric field on second plate due to first plate is Q by 2 epsilon naught A. See, we want to find out force on second plate. This plate, what is the force acting on this one? So F21. What now here? Q into E. We know charge into electric field. Charge na plus Q. Electric field na Q by 2 epsilon naught A. We can write Q square by 2 epsilon naught A. Force on second plate due to first one. So force on first plate same will come now. Why? Because area same, charge same, medium same. So we can write F force on first plate due to second plate, what? Q square by 2 epsilon naught A. Same forces acting on this one. F12 equal to F21. So both are same. This is the force exerted on one plate due to other plate. Yes na? Next we discuss. So for example, if so means what I write here. First problem. Next problem. It is very important. See what if we have a different charge on each plate, on each plate, how the charge will be distributed on inside and outside. That what if we have different charge on each plate? So distribution of charge on each face, charge distribution on each face, each face. So different charges is there on plate. That case, how the charge will be distributed inside face, outside face, that we discuss. See here, it is the parallel plate. See, one plate, this is another one. We can say this is parallel plates. Yes na? See here, charge is q1, here charge is q2. See here, it has charge q1, it has charge q2. Distance is here d. Distance is what here? D. Area also same, it is A, it is also A. See here, here charge q1, here charge q2. Different charges is there on each plates. That case, what is inside charge? We don't know. That we can take q. Here outside charge q1 minus q na. So we get here. In the same way here also, here charge we can consider x. Here we consider q2 minus x. This case, what is the charge on this face? What is the charge on this face? That we can find out. For that, what we can take now, we know one condition. Electric field inside the conductor is 0 under electrostatic condition. It is the conductor na, so means in this one here a point, so means this face, this inside the conductor a, so that is electric field inside the conductor a is plate a na 0, electric field b plate 0 inside the conductor is 0. So we can take this one, see here electric field is same, so we can take this condition and we can do the what is the charge on each face we can find out. See for example, electric field on plate A due to, what is the electric field on plate A? That's one. See this one, this side, this will be this side. So means we can write electric field due to this charge, due to this charge, due to this charge, due to this charge. What is the formula for electric field? See, electric field formula is Q by 2 epsilon naught A for single plate. Here electric field on this plate and we find out here now. See electric field on due to this one, this direction, remaining will be this direction. We can write here electric field due to this charge. Q1 formula is what? Q by 2 epsilon naught A. Q1 minus small q by what here? Epsilon naught is medium, A is the area. We can write here 2 epsilon naught A minus this one. So this minus q by 2 epsilon naught A minus x by 2 epsilon naught A minus what now here q2 minus x by 2 epsilon naught A. Yes now see, this will be outwards, remaining will be this direction. See, we can due to this one electric field, right? Minus this one, minus this one, minus this one. See here electric field on A plate A. See here 1 by 2 epsilon naught A is common, so we can write here q1 minus small q minus x minus q2 plus x, minus x plus x cancel. What we get now here, it will changes to here. So electric field inside the conductor is 0, this value is 0, means it will changes to here 0 equal to q1 minus q minus q minus 2q minus q2. So 2q changes to here, 2q equal to q1 minus q2. We can get q equal to what? Q1 minus q2 by 2 we can get. What is the charge now? Q equal to q1 minus q2 by 2. It is the charge on this face we can get. See here what we are doing now, electric field inside the conductor is 0, we can take due to this one, this is their electric field, it will be same. See here this minus this one, this one, this one we can subtract, we get this one minus this minus this electric field we can remove. So what we get here, 1 by 2 epsilon is common, so q1 minus q minus x minus into plus minus 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 plus, so minus x plus x cancel. So this electric field inside the conductor is 0, so that's why it will turn 0 0, it will changes to here 0 into something 0, we can get q minus q1 minus 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 2q minus q2. So 2q changes to here plus, so q equal to q1 minus q2 by 2. So we want to find out q1 minus q. See here q1 minus q we know, so q1 minus q means what? Q1 minus q2 by 2. Yes na, see here LCM na, 2q1 minus q1 plus q2 by 2, 2q1 minus q1 here plus q2 by 2. So means what is the na, q1 minus q equal to this one we can get. So means here this value is q1 plus q2 by 2, this value is q1 minus q2 by 2. Yes na. So next we find out this phase and this phase, so the for that we can take, so second phase we can take. See here this one we can take, this electric field minus this one, this one, this one we can do. See here electric field due to second plate inside the conductor is, so we can write, so electric field on second plate, so this one q2 minus x by 2 epsilon naught A. What is the electric field formula? Q by 2 epsilon naught A. So means each plate na this one single plate. So Q2 minus x is the charge, 2 epsilon naught A. For this one minus we can write minus x by 2 epsilon naught A minus this charge, means minus q by 2 epsilon naught A minus this charge means minus q1 minus q by 2 epsilon naught A. Yes na, see here electric field inside the conductor B is 0, so we can write 1 by 2 epsilon naught A common here, q2 minus x here, minus x minus q minus q1 plus q. See here minus q plus q cancel, what we get now here it will changes to here 0 equal to q2 minus 2x minus q1. See 2x changes to here 2x equal to q2 minus q1. Yes na, x equal to what we can write now here q2 minus q1 by 2 we get. Yes na, this is the charge on this face, so this we can write. See here we can write this one or we can write this one or minus of q1 minus q2 by 2 also we can write, either q2 minus q1 by 2 or minus of q1 minus q2. So this value is minus of q1 minus q2 by 2, this one. So now we can get, so one more discharge we want, so means q2 minus x, so q2 minus x means this one q2 minus q1 by 2. See here LCM 2q2 minus q2 minus into minus plus q1 by 2. So 2q2 minus q2 q2 plus q1 by 2. So it is q2. What is the q2 minus x form charge na? This one is q1 plus q2 by 2. So here also we can take electric field inside the conductor is 0, electric field on B we can write this electric field minus this one minus this one minus this one we can get, so it value 0. So from that we can get what is the x value q2 minus q1 by 2, or we can write minus of q1 minus q2 by 2. It is the charges on each phases. So we can write now separately and do the problems. See one more problem is there, so we can do. See now I write problem, sorry formula, and then we can write. See what na, for example see here what is the formula. See this is the parallel plates. Yes, see it has charge q1, it has charge q2, its area A, its area A. What is the distance now here this case, what is the charge on in this one now q1 plus q2 by 2. This is the charge distribution in this one q1 minus q2 by 2, here minus of q1 minus q2 by 2, here q1 plus q2 by 2. This is the formula for when plates have different charges, that case what is the charge on inside face q1 minus q2 by 2, here q1 plus q2 by 2, here minus of q1 minus q2 by 2, here q1 plus q2 by 2. For example see one problem we can do, here plate is there. See this plate has charge is here 10 microfarads, sorry 10 microcoulombs. Yes na, here see one more charge here, see it has charge is minus 4 microcoulombs. This case what is the charge on in this one, what is the charge on in this phase. So for this phase na what is the formula q1 plus q2 by 2. So means, so q1 plus q2 by 2 means what we can write here 10 minus 4 by 2 means 6 by 2 means 2 ones 2 threes means what is the charge here 2 microcoulombs. What is the charge here 2 micro, sorry 3 microcoulombs charge is there in this phase. See here q1 minus q2 by 2 formula what we can write, see here q1 10 minus of minus plus by 2, so means 14 by 2, so 2 7 jar means 7 microfarads, so 7 microcoulombs. What is the charge here 7 microcoulombs. This one automatically why na q1 minus q2 minus of now here by 2, now we can write here 7 microcoulombs minus here same 3 microcoulombs. Yes na, see for example another one here, see one more plate is there, here we can write 8 microcoulombs, here charge is, see here 6 microcoulombs, what na charge here 8 plus 6 14 by 2 means 7 microcoulombs, here 8 minus 6 2 by 2 means 1 microcoulomb. Here minus 1 microcoulomb. Here 7 microcoulomb. Like this, charge will be distributed on each faces. It's now when different charges in there. That case, this is the formula q1 plus q2 by 2. Inside na q1 minus q2 by 2. Here inside is minus of q1 minus q2 by 2. Outside is q1 plus q2 by 2. Yeah. So means please see my videos, subscribe the channel, share to your friends and relatives. It is very good content. Please see the videos and subscribe the channel. Thank you.